Wow, what a great introduction. I think that's my favorite introduction ever. Thank you, Marcus. Yeah, I wrote this book with Barry and Joanne because basically we wrote this book and everyone was like, oh yeah, that makes sense. And then they tried to do it and then they couldn't because of all this other stuff. And so I was talking to people and they were like, yeah, but we can't do it because of this. And so I got all the things that they said they couldn't do it because of and wrote a book to explain why that was all bullshit and why they could actually do it. So it's basically it's a book to arm yourself with when people say, oh, that's a great idea, but we can't do it here because of X. And you can say, well, actually, so I don't know if you'll make many friends by doing this, but, that's I can't help with that. So if you were here for my workshop, this is the too long don't read version of the workshop, so you probably won't learn anything new. So please go and see something else instead, unless you're happy to sit here for 50 minutes and have me retell you bits of the workshop. I won't mind if you leave. And even if you didn't come to the workshop, I still won't mind if you leave. That's fine. So, why scaling Agile doesn't work and what to do about it. I'm going to get straight to the point. The reason scaling Agile doesn't work is because Agile is just one piece of the puzzle. The industry standard process for software development in most companies is still a process that I like to call water-scrum-fall. And I stole this, by the way, from a guy at Forrester called Dave West. And the problem is this. Even if you're doing kind of nice iterations here, I'm going to try not to break all the cables while I do this. Yeah, that's better. Even if you're doing kind of agile stuff here, often it's the case. Who works in a company of more than 1,000 people? Okay, so who... if you work in a big company, and even if you work in a small company, you probably have this thing where before anyone does any work, you spend months. If someone has an idea, you have to go and write a budget proposal. It has to go through the budgeting cycle. You have to go and do big, long estimates and work out how much it's going to cost and how long it's going to take. And then you have to do the design phase. And then eventually some enormous document lands on someone's desk. And then you can start development. And we're doing development in nice little iterations, and that's great. But you can't actually release anything. Before you do that, your work and the work of the other teams has to be integrated, and then it goes to central testing, and then hopefully you manage to fix some of the bugs you found in testing, and then it gets tossed over the wall to IT operations, and only then does it actually go out to users. And this is the point when we actually derive measurable customer outcomes from the work. And so this overall cycle time, or lead time, depending on how you define the words, the time from golf course to measurable customer outcome, is usually pretty long. And making this bit in the middle agile usually doesn't make a big difference. It might make a difference of a few percent, but I mean, whenever I go and do value stream maps at companies, it's usually like, oh yes, this bit takes 9 months, but let's not talk about that because we can't do anything about that. And I'm like, whoa, that's the bit you need to fix. Because it doesn't matter how much you mess around with this stuff. If it's taking you 9 months to go through this, you're not making a big difference on the overall outcomes. So who has who works at a place where you have this experience, or maybe you have a friend who has this experience? Okay, so most of you. All right, so good. You're my audience. So first of all, what tends to happen when you do kind of agile in this environment is you end up creating a lot of teams. And the way that is usually made to work is you still have to do all this stuff, and then you take all the work and you break it down into lots of tiny little bits. And then you hand the tiny little bits out to all the teams, and they go off and do the tiny little bits. And then at the end, they come together and kind of try and make the system as a whole work, and it doesn't. And you have to spend weeks or months actually trying to make it work. And when it does work, you find out that it wasn't really what you wanted. And you're like, oh shit. But now we have to release it because it's taken us a year or 2 years to get here. And it's on scope, it's on time, it's on budget. So yay, so you release it. And then maybe like me, you had the experience where you rolled off the project and you went to do something instead. And then like a year or two later, you were talking to one of your colleagues who's still on the project, and they're like, oh yeah, that thing that we built, no one actually ended up using it. It was cancelled, or it went to market, it wasn't successful. And that for me was the most miserable moment of my career. This thing that I built, that I spent a year on this large team, where we thought it was a success. But then the thing actually never ended up making a lot of money for the company, and after a couple of years it got cancelled. So Agile doesn't fix that problem. Because fundamentally, the problem is the idea that you had at the beginning wasn't the right idea, but it took you so long to find out that it wasn't the right idea that you were screwed. And then you look at the decision-making process. So I love running surveys. Surveys are a really rich source of confirmation bias. And I ran a survey with Forrester to find out about Agile practices. One of the questions we asked is, how do companies make investment decisions for products? So, 47% of people replied that the committee decides from potential options, so decision by committee. 24% of people said they use some kind of financial modeling. They use economics to make their investment decisions. Woo! That seems like a good idea. For a joke, we put opinion of the person with the highest salary wins out. And you can see I spelled salary wrong here, so sorry about that. But 13% of people answered that that's how they made decisions. This is called the HIPPO method, the highest paid person's opinion. And that really is the same thing as committee decides from potential options. So that and that are actually the same thing. And then 9% of people said they use a product portfolio approach, which is also the same thing as this. And then 7% of people, which I thought was very admirable, said that they take no systematic approach, which is basically also the same thing. So what we can see here is that 76% of people are not using an economic framework, and 24% of people are using an economic framework, which is kind of depressing. So that's the state of software development and portfolio management investment today. And in most big companies, what you find is the output of this process is a few very big projects, because somehow the annual budgeting cycle leads to a few big projects being the ones that get funded. And so who has like a retirement savings account? All right, so I've got a product that I want to sell you for your retirement savings account. And in my product, I have 4 big things that I'm building. And it's going to take me a really long time to build them. And at the end, we don't know if they're going to be successful or not. And it's going to take us a really long time to find out. But if they are successful, they might make lots of money. Would you like to invest in my product? No, because you're not stupid. And yet, that's exactly what we do with the IT budgeting process for building projects. In most cases, we'd be better off taking our money and putting it into unit trusts. That will provide a better return on investment than our IT budget investments. And the things that we do to mitigate the risk of being wrong don't work. So the main activity, what's the main activity we perform to make sure that we should really do the project? The main analysis activity. Huh? Business case. And what's the main kind of analysis activity we use to create the business case? So return on investment is the main thing we want to know about, but what do we spend our analysis time doing to find out if we'll get return on investment? I would love to know that people actually put effort into finding out the potential business value. That's not where I see most people putting their effort in analysis. What I mainly see the effort being is estimation. So estimation of cost. That's where I mostly see people putting in a lot of time and effort, is working with the developers to estimate the amount of work they're going to do. The problem with that is it's pointless. So there's a guy called Douglas Hubbard who wrote a book called How to Measure Anything, and he's been looking at business cases for many, many years. And he does a kind of analysis called Monte Carlo. In Monte Carlo, you change the inputs to the business case and you see the impact of changing the values on what you care about, which is normally either return on investment or life cycle profits for the products. Those are the 2 variables you care about. And what he found is that the cost has a very low information value. Varying the cost actually doesn't have a huge impact on return on investment or life cycle profits, which is what you really care about. The single most important unknown, he found, is whether the project will be cancelled. The next most important variable is the utilization of the system, including how quickly the system rolls out and whether some people will use it at all. And those are the two things that you care about. Is it going to get cancelled? And when it rolls out, are people going to use it? And that's true for internal IT projects and for external product development, is are people really going to use it? And that's the thing we don't normally spend a lot of time finding out. And that's, for me, the whole point of the lean startup, is how we can cheaply run experiments to find out if people will actually use it and pay you money for it. And that is way, way, way more important than any kind of estimation activity. And yet it's much more rare to find people doing that than it is to find them spending, weeks or months doing kind of very detailed estimation. And then once you've done the estimation, you take all the little bits, you basically break it down into little bits, estimate the little bits, add it all up, and then you give the people all the little bits to do, and we're back where we started. So the other problem with this approach is that we create these huge projects. And when we create huge projects, we batch up all these little bits of work together in one big batch, which we then push through the process. And part of the reason we do that is because the transaction cost of taking work through the entire value stream is so high. And so part of the point of continuous delivery is to make it economic to work in small batches so we can get the feedback much more quickly. So that's kind of a quick preview of the continuous delivery thing. But when we batch up work, what we do is we batch up the very high value things with lots of very low value things, and you push them all out together. There's a really good case study called Black Swan Farming Using Cost of Delay. This is a case study that was done on Maersk, which was the world's biggest or second biggest shipping line. So a really big company with lots of IT projects, and they had about 3,000 different features that were going through the value stream from analysis through to development and delivery. And one of the first things they did was try and estimate the value of these pieces of work. And they did this using a method called cost of delay. So if you go to this link here, you can download the paper. I really highly recommend this paper as a case study of how to implement lean agile at scale. But what they found that was really interesting is by using cost of delay to measure the value of the features. So what cost of delay is, briefly, is how much it costs you per unit time, per week in this case, to not deliver the feature. So every week that we're not delivering this feature, how much is it costing us in opportunity costs to not deliver it? And that's the way that you can prioritize work in dollar value, by considering the opportunity cost of not delivering it and comparing it. And what they found is of these thousands of requirements that were going through the system, there were about 3 that it was costing the company between $2 and $2.8 million per week to not deliver. And then you've got this long tail of features where the cost of delay is negligible in comparison with this. And so it becomes very clear, what should we work on? You've got this big IT team. They should stop doing everything except these 3 bits of work and deliver these 3 bits of work as fast as they possibly can and stop doing anything else. And when you're not even exposing the value of what you're doing, and they were making assumptions to come to these numbers, it can be quite hard to work out the dollar value of these features. But when the variability is quite high, it doesn't even matter when there's like an order of magnitude difference between the value. It doesn't matter if I'm wrong by a factor of 2. Who cares? It's still going to be really obvious which the features are. And Joshua Arnold's done a bunch of other projects where he's analyzed things in this way, and he's found that this shape, this is a power law curve. This kind of power law distribution is very, very common. Most places where they've gone and looked at the value of the features, it's been this power law curve. So this is pretty typical of what you'll find, is that a few small, very valuable things get batched up with a ton of other stuff that's low value. And then when you have these big batches of work going through the system, it's really hard to prioritize the individual bits. So, what do we do? First of all, the whole project paradigm is based on the assumption that the features and requirements that we've created are in fact the right thing to do. Almost always, as we'll see, That's not true. They are the wrong thing to do. About 2/3 of the time, the features that we want to build have zero or negative value and are not the right thing to do. I have data to back this statement up, which I will give you the reference to. Um, in the case of new product development, the numbers are much, much worse. It's more like 90% of the time the product's the wrong idea. So for established products with well-known business models that work, 2/3 of the time the features are zero or negative value. With new products where there's a larger amount of uncertainty, over 90% of the time it's the wrong idea. So we shouldn't optimize for the case where we think we're right about what we're building, which is what the project paradigm does. Instead of focusing on cost and spending a lot of work on estimation, we should focus on value and gathering information to justify the value of what we're building. One of the most important things we can be doing is creating feedback loops throughout our delivery process, and making sure that the decisions we make, whether that's the product development decisions, the investment decisions, the requirement decisions, are actually the right thing. How can we get the feedback on those decisions as fast as possible? And then, within the development process, we want feedback loops. Did I break the system? Did I introduce a performance degradation? Did I introduce a security hole? This is part of the point of continuous delivery in the deployment pipeline, is to create really effective, rapid feedback loops within our delivery process. The point of continuous delivery is to make it economic to work in small batches, and working in small batches is what allows us to get these feedback loops working, so that we can get those feedback loops operating at a high frequency. By working in small batches, we get feedback at high frequency, and that allows us to course correct much more quickly, which is the whole point of Agile. And when we've done these things, then we can enable an experimental approach to product development based on the scientific method. I have a hypothesis about a feature that I want to build. How do I test whether my hypothesis is correct? What data can I gather to validate my hypothesis? And we can apply this experimental approach not just to product development, but also to process improvement, and continually work to improve the quality of our development and delivery processes. So the first idea that I want to attack is this idea of requirements. Whose requirements are they? Are they the user's requirements? Users don't know what they want. Users know what they don't want once you've built it for them. They're the requirements of the hippo, the highly paid person. And so I don't like this word requirements. What we have is hypotheses. And typically, there's more than one way to achieve the outcome we want to achieve. And a lot of the time, we're not even thinking about the outcomes. So who uses stories in their projects? As a, I want, so that, yay. Okay, lots of you. Okay, keep your hands up. If you've written a story where you kind of left out the so that because it was kind of a bit hard to think about it, keep your hand up. I have. Yeah, most of us have done that at one time or the other, and it's actually pretty common. Who's worked on a project where like the so that is missed out most of the time, like more than 50% of the time? Yeah, so that's life. But I think we all know that that's the most important bit, but in the day-to-day kind of work process, it's kind of easy to forget that because you know that it's important and we've got to do it, so let's just do it. I think we should focus much more on the outcomes. So one of my favorite tools is this one by Gojko Adzik called impact mapping. It's a very simple idea, but it's very powerful. And his idea is this: we should work backwards from the outcome. So this is the outcome we want to create. This is just an example, right? Reduce transaction cost by 10% for a trading platform. So this is an impact map for a trading platform. Reduce transaction cost by 10%. Who are the stakeholders? Well, there's a German settlement team. I didn't plan, by the way, that I would deliver this in Berlin. It just happened that way. There's some traders. There's IT operations. Here, at the second level, are the ways in which these stakeholders could help or hinder this outcome. And then at the next level are the actual stories. This is the what you could do to achieve that outcome. And when we do analysis, what happens is you pick one, and then you throw everything else away, and then that one thing is what goes downstream to development and then to IT operations. And that's a real problem. A lot of the time, the developers never even see the rest of this map. They just get improve exception reports so that, trading costs go down. And often the number, which is really important, like how are we going to measure the success of whether we're done, is thrown away. So actually having, the key thing about the impact map is not creating the impact map. The key thing about the impact map, as with most agile practices, is the shared understanding of the whole team, which is created when you build the impact map. So we have this thing in Agile that's everywhere, where you focus on the artifact. The artifact's not the important thing. The shared understanding of the team that created the artifact is actually the important thing. So here, what's crucial is having the developers and the operations people and the business people all work together to create the impact map, and then pick one. Like, which is the thing that we think will be the smallest possible work for the biggest outcome? Because as Jeff Patton likes to say, what we want to do is minimize output, maximize outcomes. So we want to maximize the outcome. What's the minimum amount of work we can do to achieve this outcome? And you pick one, and then you design an experiment to test whether it will in fact achieve this outcome. So the other thing I really like that fits with this really nicely is Jeff Gothelf's template for hypothesis-driven delivery. So instead of the story format, he has this format. We believe that building this feature for these people will achieve this outcome. We'll know we're successful when we see this signal from the market. What's the signal we're going to measure to prove that the thing we're building will actually achieve the outcome? So we believe that building this feature for these people, will achieve this outcome. We'll know we're successful when we see this signal from the market. What are we going to measure to demonstrate that the feature will actually deliver? And there's many ways we can measure the outcome using an experiment. Most of this comes from the UX movement, and one of the big trends in Agile is integrating UX. But often what I see, maybe you have friends who have this problem, is UX is basically making it look pretty. That's not the point of UX. The point of UX is to help us think about delivering things in a way that will satisfy our customers. So the whole way in which our customers interact with our products and our company is all within the realm of UX, including will the features, will the product actually make our customers happy and our users happy? So this is from Janice Fraser, and she divides up user research based on whether it's quantitative or qualitative, and then whether it's evaluative or generative. So generative, in design thinking, there's two phases. There's the bit where you generate ideas, which is where you kind of come up with lots of different options. So building an impact map is an example of a generative behavior. And then evaluative is when you narrow down the options and pick one. So that's a conversion activity. That's the process of deciding which option is the right one. So you can use user research to create a whole bunch of ideas, and then you can use different techniques to find out which of those ideas is actually going to produce the required outcome. But there's loads of ways to do this that don't involve actually building out the whole feature. And so we should be thinking very carefully about how we can gather data without building out the whole feature and then finding out whether it was a good idea. Because usually what happens is, even if you find out it wasn't a good idea, there's the sunk cost fallacy. You don't want to admit you've spent all this time building this thing that's useless. Who's actually deleted a big feature from their product in the last year? Okay, that's pretty good actually. I'm pretty impressed. Did you delete that because you were like, this isn't delivering us value? Cool, well good for you. That should be more common than it is. So in terms of an alternative to water-scrum-fall, I like to show this slide from Amazon. This is from 2011. They're about an order of magnitude better right now. They're making changes to production on average every 11.6 seconds, up to 1,079 deployments per hour, up to 10,000 boxes receiving a deployment, up to 30,000, on average 10,000, up to 30,000 boxes receiving a deployment. Who was at Nicole's talk last night? Okay, lots of you. So I won't spend too much time on this. But one of the reasons they did this was to get this, which again Nicole showed. So Ronnie Kahavi helped to build Amazon's experimentation platform. He was in charge of Amazon's experimentation platform. Then he went on to work for Microsoft and was in charge of still in charge of Bing's experimentation platform. So he has loads of data from feature development. And this is, I mean, this is the important piece of data. We could be spending 2/3 of our time on the beach, skiing, at home with our kids. If only we knew the 2/3 of the features that we build that have zero or negative value to our company. And people don't think of the negative value case, the case where you're actually making things worse. And that kills us in 3 ways. Firstly, there's the opportunity cost of not building something that would have delivered value. Second, features add complexity to our system and they have to be maintained forever. So the maintenance cost. And third, that complexity slows down the rate at which we can add new features. So it makes new feature development slower. So if you're not doing experiments to find out if your features are actually valuable, you're killing yourselves in these three ways. It's the biggest source of waste in software delivery, is the stuff that we build that delivers zero or negative value. And so who is actually running experiments to test the value of the features and products they're building? Okay, there's a few of you, maybe 10 hands went up out of the whole audience. Like, this is the biggest thing, in my opinion, that we need to change in our industry, is be thinking about how we can actually gather data to validate whether the things we're doing are actually delivering value for our customers. And it doesn't need to be A/B testing, it could just be other forms of user research. The cool thing for me about software is that software has different characteristics from architecture in terms of buildings, right? So people often say, I wish software could be more like buildings, meaning that they wish it could not fall down and be reliable and be secure and things like that. But actually, I think that's false. We don't want software to be like buildings, because software has these really unique affordances. Software is easy to change, even at scale, compared to buildings. If I want to re-architect this building, I have to pull it down and start again from scratch. You don't have to do that with software. Lots of people do that with software, which is unfortunate. But you can actually rebuild the plane while it's in flight with software. You can make architectural changes incrementally. It's entirely possible to do that. People have done that very successfully. Software is much cheaper to change. You can get value from software before you finish building it. Like, you couldn't be in this building if there were no ceilings here. But I can develop a piece of software which doesn't serve all of your needs, but might serve the needs of a small segment of you, and you might be able to get value from that from really early on. So software has these unique affordances that makes it much easier to experiment and try things out. And we can't do that with buildings and with physical architecture. And what's cool about that is we can use the same techniques for experimental product development that the lean movement has been using for years for process improvement. So to show you what I'm talking about, I'm going to give you a case study. And the case study is from HP's LaserJet firmware division. I've talked about this before, maybe you've seen me, but I'm going to focus on how they made the transition. So this was a team that in 2008 had this really big problem, which is that they were on the critical path for software development. Every new range of printers they wanted to launch, they were going to have to build new firmware, and that was going to take longer than actually building the chips that went into those printers. So that was a really serious problem. I actually did some work for a European airline, and they were introducing, the economy seats with bigger gaps between the seats, right? Like premium economy, more legroom. It was going to take them longer to change the booking system so that you could book the seats than it was going to take them to put the seats into the aeroplanes, right? Which is how you know there's something really badly wrong with your software delivery process. So it's the same thing here. It's going to take them longer to build the firmware than it was going to take them to fabricate these custom chips, which had a 1-year lead time to be able to build. So they tried a whole bunch of different things, and eventually they decided to look at their software delivery process. And what they found is they were spending a whole bunch of time doing non-value add things like code integration, very detailed planning, porting code between branches. Every time they released a new line of devices, they took a branch in version control, which meant that when they fixed a bug in one line of devices and they needed to port the bug fix, they would have to port it across all these code branches. Same with features. They were spending 25% of their time porting features and bug fixes across branches. 25% of their time on product support. What does this tell you? Quality problem. 15% of their time on manual testing. If you subtract this from 100%, what you find is that only 5% of their investment was actually being spent on building features. And by the way, all the product management people, they would say, can we get budget for, adding test automation? Can we spend some time refactoring? And management would be like, no, you've got to build the features. Who's had that happen to them? Right. And it's very clear to see the fallacy in that idea. Because here's the thing. The reason that there's all this pressure to build the features, the reason you're going so slowly is because you're spending all this amount of money on things that are not adding value. The only way you can get out of that problem is by fixing this, by removing this. That will allow you to go faster. So you have this vicious cycle. Pressure, you have to do the features. Why is the pressure there? Because we're doing all this other stuff. It's so painful to deliver anything. And if we don't fix this, it's always going to get worse and worse and worse until we're just driven into the ground. They also looked at their cycle times. It was taking a week to get changes into trunk. They were getting 1 or 2 builds a day, and it took 6 weeks to do a full manual regression on their software before they could release it. So they didn't want to do continuous deployment. They didn't want to release new firmware 10 times a day. I mean, who's upgraded their printer firmware? Okay, there's a few yak shavers in the audience. That's good. Most of the time, you don't want to upgrade your firmware 10 times a day. But what they found is by implementing continuous delivery, by working in small batches, it changed the economics of the software delivery process. Because it created feedback loops that enable them to build quality in rather than try and test quality in at the end. And over the course of 2 years, first of all, they re-architected in a big bang way, which is always very risky, that I don't recommend it. But in this case, it works, and I'll explain why later. But they re-architected such that they didn't have branches for different ranges of devices anymore. Instead, they had one firmware build that would work on any set of devices. So the firmware boots, looks at the hardware profile, says, oh, I'm a printer, I'm going to turn these features off, I'm going to keep these features on. Or it boots, looks around and says, oh, I'm a scanner, so I'm going to turn these features off and turn these features on. So it's basically feature toggles for architectural differences. A guy I know called Dan Bodart has a saying, feature branching is a poor person's modular architecture. So this is a case where they re-architected so they wouldn't have to use branches, and that allowed them to work on trunk and do continuous integration and build a very sophisticated test automation suite where they had over 30,000 hours of tests that would actually send signals to the logic boards and then get signals back as part of their test automation. So anyone who complains about test automation for websites, I don't have it today, but I often carry around a copy of this book to spank people who whine about test automation because here's people who did it with logic boards. That's super cool. So they built a very sophisticated set of automated tests. Anytime anyone checked in, they used Git. So every developer, 400 developers, by the way, so at scale, 400 developers on 3 different countries, Brazil, USA, India, all pushing changes into Git. They each had their own little repo, and they built a CI tool that looked at those repos. Anytime someone pushed a change, it would take that change and run 2 hours worth of automated tests against that change in a simulator. If that works, it gets promoted to the stage 2. And then what happens in stage 2 is all the changes in the last time period get merged, and then they run automated tests in the simulator against that merged set of changes. If that fails, the developers get an email, here's the test that broke, here's a button to be able to reproduce those test failures on your development workstation. That's super important. If developers can't reproduce the acceptance test failures, that's a very serious problem. It's an architectural problem that you need to fix. If they succeed, that's the only way you can get into trunk. So to get into trunk, anything that passes stage 2 gets into trunk, and that's the only way the developers can get into trunk. So this basically fixed the problem where the build's always red because the developers don't care about it, because guess what, the only way you get into trunk is if the build is green. Out of level 2, this runs on a big rack of servers in the simulator, another 2 hours worth of automated tests. Then you get promoted to level 3, which runs actually on physical logic boards with emulators. And then, if that works, then it gets promoted to the overnight level 4, and that's the entire 30,000 hours worth of tests run in parallel, so you get the results overnight. And so you can find out if the firmware is releasable within 24 hours of making the check-in. So they completely removed the 6-week stabilization phase. That just goes away. And the whole point of continuous delivery, by the way, is to get rid of this whole thing. Like, this whole thing should all go away. Even if you're not releasing 10 times a day, you should be able to release. Your software should always be provably releasable on a daily basis. That's the point of continuous delivery. And so even if you're not doing continuous deployment, that produces huge benefits. They massively reduce the amount of time they're spending on code integration and on planning and on porting code between branches. Product support activities go down from 25% of cost to 10% of cost. What does that tell you? Higher quality. So this is how they measured the quality improvement. Manual testing goes down from 15% to 5%. Costs invested in innovation go from 5% to 40%. So 8x improvement in productivity measured in terms of the amount of investment going towards innovation. What do the arithmeticians in the audience notice about these numbers? Less than 100%, because there is a new activity. Creating, maintaining, evolving the suites of automated tests. If you went to your manager right now and said, please can we invest 23% of our budget in test automation, what would your manager say? That's a rhetorical question. And yet here we have the business case for doing that. The business case is quite clear. Despite the fact you've got 23% of your budget spent on test automation, that has enabled an 8x improvement in cost spent on innovation, because it's massively reduced the amount of non-value add work we're doing. And this is how lean works. Lean works by investing in removing waste so that you can increase throughput. And the reason I like to talk about this case study is because they wrote it into a book, and you can get the book. And here are the numbers to take to your CFO to explain why they should invest in continuous delivery. What's interesting, and what I'm going to spend the last few minutes on, I have 10 minutes, right? Yep. Is how they did it. Because how they did it was really interesting. They did not create a 3-year plan in detail of how they were going to do this. What they did is they had a goal. Their goal was twofold. 1, get firmware off the critical path. Goal 2, 10x productivity increase. So that was it. That's all they wanted to do. They had no idea how they would do it. But they set these 2 very measurable, easy to understand goals. Like, everyone in this room can understand those goals. It's really obvious, and it's really obvious when you've achieved them and when you haven't achieved them. That's super important. Anytime you're implementing Agile or DevOps or any methodology, step 0 is to understand your goals in measurable terms. What goal are we trying to achieve? How will we know when we've achieved it? There's acceptance criteria for organizational transformation. What's our goal? If you implement Agile because Agile is cool or because it will make things better, you will fail. You've got to understand what the goals you're trying to achieve are for your organization in measurable terms. And then we want to take an experimental approach to achieving those goals. So, what's some intermediate goal which will get us some of the way there? Let's try a bunch of things out to find out if we can achieve that intermediate goal. If we don't succeed, we've learned something, but we haven't spent too much time learning it, which is important. And if we succeed, that's great. Let's try the next step. So this is crucial. We're taking an incremental approach to process improvement and to changing organizational behavior. in the same way that we take an incremental approach to product development. And that for me was like the big aha moment I had writing the book, is, well, guess what? The incremental iterative approach doesn't just apply to how we do product development, it also applies to how we do process improvement and how we improve our companies and our processes. And it's something we should be doing habitually as part of our daily work. And what was cool is that this was a case study for something that only got written about subsequently, which is true. I mean, they were doing continuous delivery before I wrote the continuous delivery book. And they didn't call it continuous delivery, they called it getting better at engineering. Right? Didn't need a name. He was just like, oh yeah, we're just trying to get better at what we're doing. And in the same way, they also simultaneously invented this thing, the Improvement Kata. So a kata comes from Japanese martial arts. It's a habit. It's a base practice that you practice over and over again until it becomes habitual. And it's the same idea as music. You practice scales over and over again. That's the first thing you do until you get really good at it. And then you move to higher order practices that combine the things you learn. Same thing with sports. You learn the basic moves for tennis, and then you're able to combine those. Any human creative activity is the same thing. You learn the basics moves first, and then until they become habitual, and then you combine them into higher order creative processes. So his point is, with this book Improvement Kata, based on the study of Toyota's management method, is that improvement work, getting better at what we do, should be a habitual process. And here's the basic practice that you have to practice over and over again in order to get better. First, understand the directional challenge. So HP LaserJet, 10x productivity increase, get firmware off the critical path. Number 2, grasp the current condition. Current condition. Step 3, establish the next target condition. So I'm going to show you what a target condition looks like, but it's basically an intermediate measurable set of goals for the program as a whole. And then you don't plan how you're going to do it. Instead, you specify the outcomes, and then you allow the people to experiment with ideas to achieve those outcomes in the same way as we do with product development. And then every day, everyone's asking themselves, what's the challenge we're trying to achieve right now? What's the actual condition? What obstacles are in our way? What are we going to try next? When can we go and see what we learned from taking that step? And so the difficult bit of this is working out the target conditions. So I'm going to give you an example from HP LaserJet firmware. This is 30 months in, but these were their entire goals for the whole program of work. 400 people on 3 continents. This was their plan for the month. It fits on one piece of paper. And this is quite long. When they started, their monthly plans for the program of work were 3 or 4 bullet points. But crucially, they had measurable outcomes. So for month 30, it was priority 1, issues open less than 1 week. Level 2, test failures, 24-hour response. Final priority 1, change request fixed, reliability, error rate at release criteria, and these are ordered by priority. So you want to get these ones done before you start on these ones. These ones are the most important. So these are all measurable. And here's the thing. Because this is the only thing that's on the program plan and it's just the outcomes, it's up to the teams to experiment with ideas to achieve those things. In most of the scaled Agile frameworks, where you break up the work into little bits, you hand it out to all the people, and then you come together at the end and it doesn't work properly, everyone says, well, I did my bit, it was those guys. Now, usually, that's not true. Usually, actually, everyone did do their bit. The problem wasn't that people didn't do their bit. The problem was that the bits didn't fit together or weren't the right things to do. It was an analysis problem. In this model, nobody succeeds unless everybody succeeds. There's no I did my bit. Either we all succeed as a team or we fail as a team. And because it's only 1 month, the impact of a failure isn't too bad. The point of failure is to expose problems so we can fix them. Not so that we can blame people for being dumb. Well, no, guess what? The reason we couldn't do it, why couldn't we do it? Oh, it's because of this. Oh, our assumption about this was wrong. So let's make different objectives for next month that address the underlying problems. So, I guess my conclusion for this is we want to take an experimental approach not just to product development, but also to process improvement. The processes that you have are the wrong processes, and you'll never have the right ones, but the important thing is to constantly think about improving your processes with a particular goal in mind, and we should all be doing that. If you leave your development processes the same, they don't stay the same. What happens is they gradually degrade over time and become worse and worse. If you're not constantly working to improve, then by default, you're gradually getting worse. And so I want to end by just what I started with. Don't optimize for the case where you're right. Assume that what you're doing is not the best thing you could be doing. Focus not on cost, not on estimation, but on how we can best provide value in our product and in the processes that we're running. Build feedback loops and grow and water and tend to your feedback loops to validate your assumptions and expose your assumptions. Work to make it so that you can get feedback in small batches, both for your product development and for your process improvement work, so that you can take an experimental approach, not just to product development, but also to process improvement. So hopefully you have a couple of minutes for questions. In the meantime, please remember to rate this session. I value your feedback. Also, if you want a bunch of my free stuff, email jezhumble@sendyourslides.com with the subject DevOps, and you'll get a bunch of free stuff, including these slides. So that's jezhumble@sendyourslides.com. DevOps. Questions? Marcus has a microphone.
Questions? Who's first?
Go
If
on.
not, I have questions from the tool,
Okay.
which are about, one guy said, it's easy to do the split testing and so on.
Yep.
What's not as easy is analyzing. And in a similar vein, it's like great that we should evaluate cost of delay or value, but how do we do it?
How do you do it? There's loads of different ways to do it. I could and have spent a whole day talking about mechanisms to do that. Cost of delay, I really recommend looking at this case study from Maersk. Like, they talk a lot about cost of delay in this case study and how to evaluate it. But the key thing is this. Anytime you have an idea, you're going to make assumptions. And people tend to fight about the ideas. This idea is good. No, this idea is good. What you want to expose is, what assumptions are you making? And let's test the assumptions and find ways to test the assumptions. And there's loads of ways to do that. Like, one of my favorite stories is from Zappos. So Zappos sells shoes online. The first version of the product, there was no supply chain. What happened was, anytime someone ordered some shoes, the guy would go to the shoe shop, buy the shoes, and then post them. So this is the art of experimentation, is finding cheap ways to achieve, to run experiments without actually building the thing. And I agree that it's difficult, but we're all software developers. We didn't get into software development because it was easy, right? So, when people are like, oh, that's difficult, I'm like, yes, of course it's difficult. Like, if you want an easy job, you came into the wrong field. But what I do agree is that it's not a very well-known, not very well established field. So what I urge you to do is come up with ingenious ways to experiment, to test your assumptions, and then blog about them and share them. Because as a community, we all need to get much better at sharing our ideas for doing these things and creating a body of knowledge around it.
One more question? Okay. I hop over.
Hi.
Hi.
I would like to ask, how do you start with this? Because I think most of the guys here are at the not the top of the food chain in a company, and so do you recommend rather buying the books and giving it as a present, a Christmas present to your bosses, or starting at your position to experiment and then show the good results?
So I'm certainly not going to complain if you buy my book for your boss, but I think you need to do both, right? There's a part of this which is guerrilla experimentation, like try and find smart ways to do this in your own backyard and experiment with it and gain confidence that it can actually work. And find other people in your company who want to try this stuff. Like, the best hack of all is finding someone who you don't normally talk to in your company and taking them out for lunch. Like, find your database administrator, take them out for lunch, find out why they hate you, find out one thing you can do to make their life a little bit better and do that. And do that once a week. Just randomly pick someone in your company who you don't normally get to hang out with. Try and pick the person who you're like cursing under your breath when something doesn't work, right? You're like, that asshole in UX again. They've sent me this terrible screenshot and I can't, idiots. Go and take them out for lunch. Go and find out what's bothering them. There's a great quote from Jesse Robbins. He says, "Don't fight stupid, make more awesome." And I think that's very important. Try and find ways to make things more awesome. And find the people who you think are being stupid, find out why. It's normally because they're really frustrated about something, or they just don't know what's going on because we don't have feedback loops, and try and find ways to help make that person more awesome. And if we all did that every day, that would be really cool. What I will say is it's hard to create lasting change without executive support. And the reason that executives change their minds is usually because there's a disaster. So there's a book called by John Kata called Leading Change, and he says the most important thing for an organizational change to be successful is a sense of urgency. So find people who are feeling the pressure. Those are normally the people who are willing to try out different things. And if you can get those people on board at the senior level and the people in the middle feeling urgency and the people on the ground feeling urgency, that's normally a good place to start. People with a level of urgency and the capability to do something about it. That's your sweet spot for this kind of thing. So again, not an easy problem, but those are my 2 ideas for helping get started with that stuff. Thank you very much.